All right, Algebra 1. Here we go again, guys. Let's jump into another note video. All right, hope you are awake, up and at 'em. Might be watching this crazy late at night, might be watching this early in the morning, might be watching this literally at school right now. Whatever the situation is, stay focused. You guys got this. All right, let's jump into it. So we are in section 4 today, chapter 7, section 4. We are solving linear systems as we have been, but this time we're going to be multiplying first before we can use elimination. All right, so solving linear systems, multiply first. All right, so I've tried to highlight some of the important phrasing and the definitions and everything that I've written out. So just pay close attention. You should read the whole thing, but basically these parts right here that I've highlighted, all that stuff, that's going to be important as we get into it today. So you're going to notice, as it says, all the terms for both equations, they may not have something that perfectly matches up. Okay, in the previous section, they did have something that perfectly matched up. We could use elimination, everything worked. But this time they may not. And so the point being is you're going to have to find, as it says, the least common multiple. So what I'm talking about is, let's say one term has a 4y, the other term has a 2y. Well, then you can make that 2y become a 4y by multiplying everything in that equation by 2. That's what we're getting into. All right. So the second note here, we are right here. All right, you may have problems where only one equation needs to get multiplied. That's nice. You may, though, have problems where both equations actually have to be multiplied by something. Now, an example of that would be, let's say one equation has a 3x, the other equation has a 5x. Well, 3 can't become 5, 5 can't become 3, but they could both become 15. So then that means each equation is going to have to be multiplied by a different number so that 3 could become 15 and 5 could become 15. All right, you're going to see me work out one of those also. So if you could take a look at this example problem right here, you see that it's already worked out. You have that 2y and that 4y. They could become the same thing if I multiply everything in this top equation by 2. Then this is what it becomes. All right, 5 times 2 is 10. 2 times 2 is 4. 16 times 2 is 32. All right, so this right here, multiplying one equation to get the perfect matching terms, and then you would go through and use elimination, just like you did in the last section, and solve it. Okay. But you may have something right here where you need to multiply both equations to match up a term. And what we're doing here is we are going to make 12 and 9 both become 36, because 12 can't become 9 through simple multiplication. That's not going to happen. So everything in this top equation is multiplied by 4, and everything in the bottom equation is multiplied by 3. All right, and then you would have to essentially use the distributive property. So 4 times 2 is 8. 4 times 9 is 36. 4 times 1 is 4. And then you're going to have to do the same thing in the bottom equation, but you're multiplying by 3. Okay, you're trying to find, as I said up here, the least common multiple that works so that you can then proceed by using elimination. All right, so take the time to read these, look through those examples, and now we're going to jump into 3 example problems of our own. Okay, so first one here we have, we'll do a little zoom in. There we go. All right, so 2x plus 3y equals 10, 4x plus 5y equals 18. And right here, these are the 2 terms that I'm going to focus on. Why am I going to focus on those? Because 4 and 2, these guys go together. 2 can become 4. So that's what I'm going to focus on, is making this 2 become a 4. That means everything in this top equation right here is going to have to be multiplied by 2. So let's do that. All right, we're going to put this in parentheses and put a 2 on the outside and distribute a 2 into everything inside, everything, all 3 terms. So this will then become 4x plus 6y equals 20. And we're going to go ahead and still use the bottom equation because everything worked out there. We have the 4x now plus 5y, and that is still 18. And so now you're looking at the 2 new equations that we're working with right here. And we can use elimination with 4x and 4x. Now, they are both the exact same sign. So if they're the same sign, we're going to use subtraction. Okay, 4x minus 4x crosses out. 6y minus 5y equals simply y. And then 20 minus 18 is just 2. So now what you're looking at is one of the variables is solved for. Now, what do I have to do to solve for the other variable? You got to plug it back in. Okay, so I am going to take y equals 2 and plug it back in to the top equation. That doesn't have to be the top equation, but I'm going to plug it into the top equation. I think it might be a little easier. And so that's going to be 2x plus 3 multiplied by 2 equals 10. 2x plus 6 equals 10. Minus 6 crosses out. 2x equals 4. X equals 2 also. So there we go. There are the 2 values that we needed. X is 2, y is 2. Let's move on to the next example problem. All right, so example problem number 2. Okay, you're going to notice a couple things. One, first thing is they're not lined up. So we need to rearrange our terms to get everything lined up. What I'm going to do is I'm going to take this 5x and I'm going to bring it in front so that I'm going to have x, then y, then my equal sign, and then my constant, because that's exactly what the top one looks like. I have x, then I have y, then I have equals, and then I have my constant. So let's rearrange the terms so that the bottom one has the 5x moved over here. So that's going to be a negative 5x plus 9y equals 5. And then we're just going to keep this one 3x minus 7y equals 5. And the reason why I'm doing that is every term needs to line up. Now I can easily see what am I dealing with here. I'll tell you what I'm dealing with. I'm dealing with a 3 and a 5, neither of which can become each other. 3 can't become 5, 5 can't become 3, but they both can become what number? 15. So everything in this top equation, I'm going to have to multiply by 5. And everything in this bottom equation, I'm going to have to multiply by 3, so that the 3 and the 5 both become 15. So let's do that. Everything here times 5. Everything here times 3. And let's see, we're going to get 15x minus 35y equals 25. And then underneath it, we're going to have a negative 15x plus 27y equals 15. All right, now I want you to notice positive 15, negative 15, opposite signs means that we will be using addition. I'm going to put it in parentheses just so that you can see that positive goes to both equations here. All right, and let's start solving it. So 15 minus 15 These guys cross each other out. Okay, then we're looking at a negative 35 plus 27, giving us a negative 8y, and 25 plus 15, giving us 40. And divide both sides by 8, and y equals 5, negative 5, actually. All right, so there's one of the variables solved for, y equals negative 5. Now, zoom out a little bit. Let's take this value and plug it in. And I'm going to go ahead and plug this in right up here to that value right there. So you're going to have 9 times a negative 5, and that's going to give us a negative 45 equals 5x plus 5. And again, I took this value right here and plugged it into that y right there, and that's what gave me the negative 45 right there. Okay, so now let's go through and solve. Minus 5 minus 5. Negative 45 minus 5 actually becomes a negative 50 equals 5x. X equals, it's going to be a negative 10. Okay, there we go. That's probably one of the toughest styles of problem you're going to see in this whole homework assignment. All right, so that's for example 2. Now, last one here, one more to go, example 3. This one's a little bit more straightforward. We've done similar stuff here. What you're going to see is a 2y and then just a y, meaning I can make this y become a 2y if I multiply everything here times 2. So let's do that. All right, parentheses, put a 2 out there, and we're going to keep the top equation the same. So 3x plus 2y equals 7. Distribute a 2, again, into all parts. All right, so that's now going to become 10x minus 2y equals 6. Okay, and pay attention here to a positive and a negative. Different signs means you will use addition. Okay, so you now have 3 plus 10 giving you 13x. 2y, negative 2y, cross each other out. 7 plus 6 giving you 13. X equals 1. All right, now this one, kind of nice. If you wanted to, you could take this equation right here. It'd probably be the easiest. And let's go ahead and use it because we're just looking at a simple minus y right there. So we're going to take x equals 1 and plug it in here. 5 times 1 is simply just going to be 5. So all you're looking at is 5 minus y equals 3. I'm going to go ahead and rearrange my terms here. Negative y, bring it over here. 3, bring it over here. And that's going to now become 5 minus 3 equals y. Y equals 2. All right, there you go. Those are the 3 example problems. Let's zoom out. That way you can see everything right there. Now remember, this is for multiply first, then use elimination. You guys got this. Work hard. Keep watching these videos. Take these notes. You got questions, ask them in class, or send me an email. All right, see you guys in the next one.